So here we are. This is the bottom of the Canvas page. We're in week 12. Today is the 11th. Is that right? Yes, today's the 11th. And so I want to talk a little bit about oral communications because that's what's going to happen the week after Thanksgiving. Just want you to know what's coming up so you won't be surprised. Talk a little bit about the final project and the specifications. They've all been out there. So if you click on 12 and module 12, you can see all the files that are available. But I just want to go over some highlights and remind you what is due this week. This week, everyone should turn back their revised experimentation reports. Okay, turn back your experimentation reports, and let me grade the revised reports. Okay, stick them all in the mailbox up there, up in room 320. Okay. I'm going to try to grade them this year without the benefit of your old reports. I used to ask you to take the old reports, put your new report on it, and turn them both in. But I'm not going to ask for that this year. This year I just want the revised one. I do still want the one-page summary that should be on top of your report that says what did you change. You know, I corrected the grammar, I added a few figures, I removed the extraneous content, just a brief summary. Okay, it should just be a few bullets. It doesn't have to be a full page of writing, but it should just be a cover sheet saying this is my revised report. These are the things I changed, so I'll be looking for those things. All right. Any questions about what is due on Friday? Okay. Then I'm going to be grading them, and you'll get them sometime toward the end of the semester. Okay. There's no meeting next week, so for the next 2 weeks, this week and next week, you're going to be working on trying to get your final project to work. Then we have the holiday break, and then the last week of the semester, we will have oral presentations and demonstrations. Now, we will have a meeting on that Monday, but the only purpose of that meeting is to turn in your teamwork evaluations. So I'm going to talk a little bit about the final project, talk about how the oral presentations are going to be graded, and then what is this thing about teamwork evaluations. So we just have a few sheets of paper to take a look at, but you can click on all these things in Canvas. So let me first talk about the final project. Okay, so this is the specification for this year. Okay, it's really the same as what was earlier in the spring. What we're trying to do is to design something that can control the speed of the motor that you've been experimenting with, and also run a digital stopwatch. So the implication is here that you need to design two things and make them both work together or not interfere with each other. And the implication is that interrupts are going to have to be used, because while one thing is working, it may get interrupted and by the other function, and then when that function is taken care of, you need to go back to what you were doing, and vice versa. So you need to talk to your lab partner about how you're going to implement these two functions. Okay, so the full credit is a list of these performance criteria, A, B, C, D, E. If you want to go for the extra credit, you can go for F. You don't need to. But the thing that I want to emphasize, and this is kind of described on the next page, and I won't talk about the details. I won't show the details, but you can basically start from here and start knocking things down one at a time. These things don't, for example, getting your keypad to work, just showing that you can get 10 different speeds. First thing you need to do is show that your keypad works. Maybe the rest of it doesn't work, but you can get at least 5 points. And then what you want to do is show that you can get at least 10 different speeds in addition to a stop condition. Okay, so you just need to get 10 different non-zero speeds. That doesn't mean that your control system is working. Your A to D converter may not work, but you can at least get 10 different speeds just by putting out 10 different PWM duty cycles. you need to demonstrate that you're doing something periodically at a rate of 10 milliseconds, 100 hertz. That's for the control system. So that must mean that the timer is, one of the timers is working. Okay? You may have a timer also for the stopwatch. Okay? The next one, it says that the desired speed is within 5%, the actual speed is within 5% of the desired speed, whether it's loaded or not. And so the way we do this in the lab is, if you got a picture of the pulley, here's your pulley, and it's spinning this way, spinning around and around. There's a hook on the board. There's a hook on the board right here, and there's a in the lab there's a piece of twine and a washer. So you take the piece of twine, do one turn around the pulley, dangle it off the table, and hang that 50-gram washer off the edge of the table. So this thing puts a little bit of tension on this, and so it is a load. You lift off the washer and there's no load. And so we want to see that whether it's loaded or unloaded, you're within 5% of the desired value. So that implies either your A to D converter is working, so you get some feedback, or you're able to time the period and again get some feedback. Separately, that two-digit stopwatch, 0.0 to 9.9 needs to be running, and you should be able to turn it on, turn it off, reset it, and we shouldn't see any variations in the speed. Likewise, if somebody were to mash the buttons that control the speed, raise the speed, lower the speed, the stopwatch should not get messed up. Okay, so you got to figure out some experiment to demonstrate that the stopwatch and the speed controller don't interfere with each other. Okay, and then finally, what you want to do is, if you have time and the ambition, and it's not necessary, you want to try to design your control system so that the response is a little bit better than what it was without control. And so what I said here is that the settling time for the control system is 1/2 the open loop time. So that means that maybe the motor's natural response is this. This is just the motor response. You took a graph of that response with respect to time last week, and maybe under control it does something like this, or and so it responds a little bit faster. It settles out to the right value. Maybe I didn't imply that these two were settling out at the same value. This is the motor is uncontrolled, but the closed loop control system should be within 5% of the desired value. Okay, and we don't want too much overshoot. We don't want too much of this going on. So this is not too easy to do. You can play with that a little bit. There's some. So that's what you're working on for the next 2 weeks. If you take a look at the lab manual online, the online lab manual, there are some suggestions for how you might approach the problem. I talked about a little bit about a type of compensator that's used in industrial practice. It's a PID controller. It's by far the most popular controller in industrial practice. But you don't have to use a PID controller to do really well in this lab. And there's a section in that page talking about things that have worked well in the past. You might want to take a look at that. And there's also a paragraph talking a little bit about some computer tools that you can explore if you want to try to simulate some of the behavior before you control things. So that's what you're working on for the next 2 weeks, and that's just the design project. Now, after Thanksgiving, we'll come back, and each team is going to do a oral presentation talking about their project. Now, I want to emphasize you're only going to be given about 10 minutes per team, and that's including question and answer, because most of the labs have 6 teams, so 6 times 10 minutes is an hour. So I'd like to be done in an hour. That leaves you a little bit more time to do final demonstrations, tear down the lab, return your box into the pristine condition that was like when you got it at the beginning of the semester. The TAs will still be grading you that last week. So I don't want to take up a ton of time doing these long, lengthy oral presentations. So, including questions and answers from the audience, we should be aiming for about 10 minutes per team. So that means you're aiming for maybe an 8-minute presentation. And so you and your partner are going to speak 8 minutes, which means that you're going to speak 4 minutes. So this is not easy to say, wow, I've done a really amazing piece of work this semester, 14 weeks worth of work, I got to get it done and expressed in 4 minutes. So it's pretty challenging. I hope it's obvious to you that you're not going to stand up there and explain the scan algorithm for the keypad controller. That's a level of detail that is way too much in 4 minutes. You need to think of this as an elevator talk. And so this is an elevator talk is when you get on the elevator with your new boss and he says or she says, oh, I hear you're the new engineer. What are you doing? And you think, wow, here's my opportunity to really impress my boss. I'm going to get my leg up on the promotion. Of course, if you're like me, you sit there and say, well, I moved in my apartment. I figured out where the grocery store was. And then you take that 30-second ride up the next floor and you get out and then you kick yourself. You say, oh man, why didn't I say something intelligent? That's the challenge you have with an elevator talk. So the question is, what can you say that's coherent, intelligent, and impresses your boss and say, man, we sure hired a good guy or good engineer from Auburn. Okay, so you need to be judicious about what you're going to talk about. Of course, think about the big picture. What is it you're trying to demonstrate? Trying to demonstrate that you got something done, so try to show some evidence that happened. This is the grading rubric that will be used. And so I'll sit back there, and the TA will sit back there. We may have a guest evaluator. I've been trying to twist Dr. Nelson's arm to come back from retirement and also be an evaluator. He and I used to do this every semester for the last 10 years. We sit back there and we put your name, we put your teammate's name, and we sit there and we listen. And then on the fly, we say, how are they doing with nonverbal skills? Are they looking at me, trying to make eye contact? How are their verbal skills? Can we hear them in the room over the air conditioning noise? How's their language? Does they sound like an electrical engineer or do they sound like an industrial engineer? Okay? No industrial engineers in here, right? Okay, last time I made that joke, I got in trouble. Industrial engineers just look at the world differently, so I would expect them to use a different kind of languages. But last time I made a joke about industrial engineers, I got in trouble. We would take a look at how about is the organization of the information, is it reasonable? Okay, and how about the visuals? Do they look okay? There's some slides I recommend you go take a look at again in module 12, talking about oral presentations. The key thing to remember here, I would say to think about for visuals is things may be looking good on the computer screen. Okay, looking good on the computer screen does not mean it will be okay projected. Okay? If it's looking good on the computer screen, don't be satisfied with that. You need to think, I'm on a computer screen, the distance from my nose to the screen is about 18 inches, maybe 2 feet. When we're in a presentation, that screen from my nose is more like 20 feet. Okay? So there's some examples, if you go and take a look at the Module 12 and Module 13, Module 14, of what 12-point font looks like. If you look at 12-point font on a piece of paper, you're going to think, oh man, this is huge. Why is he using a 12-point font? Is he like trying to take up white space? Well, that's true on a piece of paper. But on a screen, it's going to look tiny. Okay, so that's the main takeaway that I want to share with you is what it looks good on a computer screen may not look good at all on the projector. So you need to keep it simple. There's a bunch of other ideas. But one of the things we do grade you on is how the visuals are. And then we will ask some questions. We want to see if we can make you cry, break down. I'll encourage your classmates to ask questions, see how vicious they are. Okay. Usually people are pretty nice. Okay. The good news is that in the 10 years we've been doing this, I can count on one hand the number of people who broke down and cried. One hand. This many fingers. So, and if you do break down and cry, the good thing is it's not the end of the world. Okay? It's not the end of the world. One of our very best graduate students broke down during the junior year presentation. And that person is very successful right now. And I'm very envious of where that person is in life. So I just say that as encouragement to you. It's a little bit nerve-wracking. Okay? 14 weeks of work, gotta say it in 4 minutes. It's not easy. There are some things that I would recommend that you think about. Please don't wear baseball caps, guys. Especially don't wear them backwards. Okay, that's just one of my pet peeves. If you wear a stud in your tongue, make sure I can't see it. It's another one of my pet peeves. Okay, ladies, the big dangling earrings, those probably are not appropriate. Okay, you're trying to make an impression as an electrical engineer, and there's a saying, you can't spell geek without EE. So it's better that you look a little bit geeky than look like you're going to a wedding or a party. Some of you, I've heard some questions about this. I've got ROTC this week. I'll probably be in uniform. Is that a problem? No, it's not a problem. I think it's great. A related question. I feel like I'll do better if I put on my power suit. Do it. Okay? Do it. Whatever makes you feel comfortable. So look up this rubric, kind of review it. And the way we grade things, like many of the rubrics, we start off with my pen right here under the word competent. And we listen. And if I can't hear you, my hand kind of gravitates this way. If I say, wow, what a beautiful voice, my hand kind of goes this way. And so it's very common that people get checks, kind of down this column, competent. But we recognize that it's just your junior year. You still got senior design to go, and there's always potential room for growth. All right. Any questions about oral presentations? Okay. I would say from my own personal experience that oral presentations are something that some of us need to practice, and I include myself in that group. I'm not a naturally good speaker. I don't have the best voice. I wish it was a few octaves lower. And I get nervous. And the only reason I'm halfway decent now in my career is because I've been doing this for 30 years or more. And this is the best I've gotten in 30 years. So you can imagine how some people who are really talented might be. So don't feel bad that you're going to be nervous. Nerves is part of oral presentations. Now, the other thing that I want to close with today is what is going to be due that last Monday that we meet. We're going to come after Thanksgiving, and we will have a meeting that Monday. That Monday, we will have a meeting, and you'll see that on that day, I'm just going to collect the teamwork evaluations. And the teamwork evaluations are also on Canvas. You can click on that link, and it's just another rubric sheet. It's 8.5 by 11 with 2 identical charts. This one, and then below it is this one. The only difference is up at the top, it says, this is an assessment of my teammate, and who is my teammate? And the other one says, this is an assessment of me, okay, my own self. Now, I would expect that most people are probably going to start off right about here. In fact, I put this down on the sheet, is that if you want to check off on your teammate, meets expectations, that's fine. No problem, you meet the expectations. But if you want to be extra nice to your teammate, or you want to kind of pass a message to me, then you can go over here. But in the fine print, it says comments here have to justify any rating other than meets expectations. We used to find that everybody thought their teammate was the best thing since sliced cheese, so they just scored everything was great. And that's not very useful. It's kind of like, it's called grade inflation. That happens in the Ivy League schools, but not at Auburn. Okay, so if your teammate's really good, we need an explanation of why they're really good. And if you're really unhappy, it's not enough to tell me that you're unhappy with your teammate. I need some details. And you can assess yourself in the same way. Okay, hopefully your initial evaluation is that you're meeting expectations for yourself. I hope we're not too prideful and put too many check marks here. But if you really have had a great semester, maybe you can give a little bit of explanation of why you think you've been a great teammate. All right? So this will be collected, this one sheet, my teammate's name, my name, this will be collected on Monday. They will not be returned. They will not be returned. Okay? So you can be honest with me about yourself and your teammate. These will not be returned to you. Okay, teamwork is also being evaluated, has been evaluated throughout the semester by your TA. They've been watching everybody work, and so I asked them, hey, how's this team been doing? Okay, and I think to be frank with you, I've been asking them all along all semester, and they haven't given me any concerns. So I hope this is a useful exercise. I'm not so concerned about the grade here, and that you'll see that the grade really doesn't count much for the teamwork evaluation. I don't expect anybody is going to drop a letter grade because because their teammate was upset with them. That's not likely to happen because the points for teamwork evaluation are not that much. So why do we do it? Well, we do it because in senior design, you're going to work on more pressure with a larger team, typically 3 or 4 people, and your contribution and your teammates' contribution is really a lot more important. And it's useful to think a little bit about what are some of the characteristics of good teamwork. For example, sharing responsibility for what's going on with the project, working with one another, looking past each other's personal differences, mutually deciding what our goals should be, and deciding how we should go forward. Things like that. Okay, so these are things that will be more important in our senior design, and this semester is just an opportunity to put it out in front of you and say, hey, be thinking about this. The senior design guys who are doing senior design this semester, they're using the same rubric and evaluating their teammates. So you'll get to see this again, and I don't know how much it counts as senior design. I think that's up to the senior design instructors. Okay, so this is primarily an exercise, but you do have to do it. You might say, well, I'll just blow it off. It doesn't count for much. You blow it off, you're going to get an IN. You're going to get an incomplete. Okay? It's just like Memo 0. It wasn't graded, but it had to be done. If you haven't done Memo 0, and you know who you are, you will get an IN. Okay? If you're not sure, check Canvas and check your grades. If you got a blank, is that right? No. Memo 0 is not graded, so there's nothing on Canvas. If you're not sure whether you did Memo 0, send me a note. If you're concerned whether you're going to get incomplete because you didn't do Memo 0, let me know. Okay, I think I've talked enough. I'm ready to go. Are there any questions? All right, have a great next 2 weeks.